You will have hand-on experience on micro-credential and digital badges. So allow me to bring you the first session of this afternoon. From 1:30 to 2:15, we're going to have workshop by Professor Yasushi Kodama, Professor of HOSEI University. He is also Director and Leader of International Collaboration Working Group of JMOOC. Please allow me to brief you his bio. Professor Kodama graduated from the Department of Computer Science at Keio University. He was an assistant professor at Tokyo University of Science. He is now a professor at Graduate School of HOSEI University. He is also director of JMOOC and director of the Data Science Center at HOSEI University. This afternoon, Professor Kodama will deliver the project titled The Approach to MOOCs Learning Environment Using Generative AI. So without further delay, please welcome him with your big hands. Thank you.
All right, thank you for the invitation, and it is very honor to be present our approaches. So before the presentation, I am very surprising to growing up to the AI technology to the Thai MOOCs, very surprising. So we are just a new approach in Japan, and Japan's situation for introducing to the AI approaches. So title is Approach to the MOOCs Learning Environment Using Generative AI by Yasushi Kodama. Then, as you know, the very third wave of AI exists. First wave is around 1960, and second is 1980s. Then around from the 2010s, just starting to the new approaches, third move of AI approaches. Then there is exist of neural networks updates, and machine learning and deep learning is just growing. So after that, just a little bit jumping up approaches, attention mechanisms, and just we talk about generative AI. So it is growing up to introduce to the generative AI and AI technology to the education environment. So we are already using to the AI approaches. At first, just predicting student performance, and LEAF is just existing to the one of the top professors, Professor Ogata, just making to just creating to the learning environment and analytics framework in Japan, and also generating various education materials using to the generative AI. Just introducing to this presentation by mainly Fujiyoshi AI sensei. Sensei means it's a teacher in English. So before that, I will introduce to our approaches. One is predicting student performance using to the deep learning or AI approaches. We just write to the performance evaluation for four types on the machine learning algorithms and educational open data. So we just creating to the new, new like this deep learning system so to predicting to the student performance A, AA, or ABC like this. Then using to the student data only to the 3 times or 4 times classrooms data, so we can predict to the G's performance, student performance using to the deep learning. So we can get to the almost 8%, 80% or 90%, we can predict to the student performance using to the deep learning. This is first time or first approach using to the AI technologies. After that, one of the mainly Japanese environment produced by Professor Ogata, just making to the new environment or leaf. This system produced like this, making to the learning record and analytics system like this. Then learning evidence and analytics frameworks. This objective is one is maximize learners' learning performances and minimize teachers' time and efforts like this. Then they making to the book roll and running analytics system and inventions and can be sent by email. So that is a very original feedback system. And also predicting the student final score. All of the system is using to the AI technology. This is a mainly introducing system in Japan right now. Also, generating various educational materials using to the generative AI. This is one of the approaches by a generalized corporation named by a teacher's copilot. This system produced the AI study note and automatic slide generation and automatic quiz generation and automatic keyword extraction and glossary generation. And finally, AI face recognition. These are maybe first approaches using to the AI technology in Japan. And also, we are mainly introducing to the generative AI assistant produced by Fujiyoshi, Professor Fujiyoshi, the Chubu University in Japan, named by Fujiyoshi AI Sensei. Sensei means a teacher. So Fujiyoshi Sensei will present to this system from the Zooms. Is that okay to the Fujiyoshi Sensei? Zooms?
Yeah.
Maybe Fujiyoshi Sensei in the Zooms is there. Could you change it to the?
To play
No, from the Zooms.
from Zoom.
It's okay.
Do you want someone from Zoom to
Oh,
appear?
yeah.
Okay. So which หน้าจอเข้า Zoom
Sorry.
ได้ไหมครับ
Yeah, it's okay.
Can you share my screen?
Just it. 藤尾先生、聞こえますでしょうか。
はい、じゃあ今からスクリーンシェアですね。
はい、大丈夫です。聞こえてますので、プレゼンテーションよろしくお願いいたします。
はい。 Hi, I'm Hiro Fujiyoshi from Chubu University. Today, I'd like to talk about Fujiyoshi Sensei. Actually, we call the video queue now. That is a lecture video search dialogue system using the LLM and RAG. Please let me give my background on myself. I earned my PhD from Chubu University. Then I moved to USA to join the Robotics Institute at Carnegie Mellon University as a postdoc fellow. There, I worked for the video surveillance and monitoring project and humanoid vision project. And I started working at the Chubu University in 2000 and have continued working in the area of the computer vision. Okay, so this is my research area, computer vision and AI. Actually, we focus on research area called explainable AI and deep collaborative learning. Okay. I'm still working on I have been working on this area for more than 25 years. Okay, so today, large language model. Large language model have become incredibly popular. But what exactly is a large language model? A large language model is a deep learning models trained on a massive amount of text data. And this uses a neural network to generate a human-like text. For example, GPT, BART, PaLM, and Cloud. And LLM can perform the text generation, summarization, translation, and more. So how do LLM actually work? So LLM uses a model called the transformer, which predict the next word based on the context of the previous word. The training process involves a massive data and relies on the self-supervised learning, where the model learns from the pattern in the data without needing explicit human-labeled examples. Finally, to refine the performance, LLM can be fine-tuned using reinforcement learning from human feedback. This helps align the model's responses with what humans expect, improving the both accuracy and relevance. So LLM has a wide range of the applications. One of the key applications is a chatbot and virtual assistants like ChatGPT and Google Bard, which help users with the conversations, answering the question, and automating the tasks. LLM are also used for the code generation, content creation, education, customer support, research, and data analysis, and so on. So today, we will focus on education, application in education. So let's take a look at LLM being used in education. AI personalized tutoring. So AI-powered tutor provides a customized explanation and interactive learning experience to each student. For example, K-Hamingo via K-Han Academy and ChatGPT can help students by explaining the complex topics in an easy-to-understand way. LLM also support language learning, assisting the grammar corrections, translation, and conversational practice. Another key application is automated grading and feedback. So LLM also assists teachers in creating the quizzes, lesson plans, and summaries, making it easier to prepare the educational material efficiently. But one of the biggest challenges in using the LLM for the education is dealing with hallucinations. In LLM, hallucination refers to outputs that contain the inaccuracies or non-essential text. There are several reasons why LLM produces hallucination. Some common causes include incomplete or noisy training data, vague questions, and overfitting model or underfitting the model, and inherent biases. So preventing the hallucination in LLM is an important task, but it's not an easy one. So while GPT-4, that is one of the large language model, LLM, is highly advanced, but there are still some tasks that struggle with. First, LLM has difficulty keeping up with the current event, since its knowledge is based on the past training data and may not always be up to date. The second, LLM isn't great at mathematical calculations. Lastly, GPT-4 has a limitation in the string manipulation like this. So, in the last version of the ChatGPT, as shown here, these issues have been addressed. One of the solutions is the introduction of the RAG. Retrieval augmented generation RAG is a hybrid AI approach that combines the retrieval and generation. So it improves the language model by retrieving the relevant external information that make responses more accurate and reducing the hallucination. So how does RAG work? So first, retrieval phase. The model searches the external knowledge like a database, API document to find the relevant information. Then, in a generation frame, the language model uses the retrieved data to generate the response, ensuring that the information is more factual and reliable. By integrating the retrieval and generation, RAG helps AI provide more accurate. So we have developed a lecture video search dialogue system using the LLM and RAG we called Video Q. So during the COVID-19 pandemic, in-person lectures were no longer possible. So I created the on-demand lecture videos. Making these videos took a lot of time and effort. It was really challenging. So now that we have returned to the in-person classes, so I made these lecture videos available to the student for the review. However, unfortunately, students are not making much use of these lectures. So I started thinking about how we could make better use of these lecture videos. Instead of just watching a video passively, I wanted to create a way for a student to interact with the content for the review purposes. So that's why I came up with the idea of the personalizing the LLM to enable a dialogue-based system that can help students search through the lecture videos. By personalizing the LLM with the lecture video, it can provide the responses that are aligned with the lecture content, making learning experience more engaging and effective. So this system is beneficial both instructor and students. For students, it allows them to ask the question anytime, 24 hours or 7 days. And for instructor, instructor can save the time on answering the questions and focus more on their research. So I believe that it's a kind of a win-win for both student and instructors. All right, so our chat system called Video Queue operates in the 3 steps. First, once a lecture video is uploaded to the YouTube, so we analyze the lecture contents and build a database. Second, we use a RAG and LLM to answering the question based on this external database. Third, we play the video starting from the relevant frames, ensuring the precise access to the needed information. The first step is analyzing the lecture videos. We automatically detect the slide transition timing from the videos, allowing us to identify when each slide changes. Then we convert the spoken content into the text for each slide, and we make a database to search reference later. The second step is LLM and RAG for the question answering. First, the student enters a question as a prompt. Then the system searches the external database using the prompt. In this case, it finds that the slide 3 is the most relevant. So next, we extract the spoken text from the slide 3 and use it as a search results. Finally, we feed the both prompt and retrieved text into the LLM, and which generates the responses based on the lecture content. So this process ensures that the system's answers are aligned with the spoken content from the slide 3, making the responses more accurate and relevant. The last is playing the video starting from the relevant frames. Since we already know which slide is related to the question and answer session, so student can watch the lecture video from the exact relevant frame. Okay, so this is an example of video queue interface. Here, you can see the list of the lecture videos, and you can enter the questions in chat panel. Additionally, we can watch the lecture video starting from the exact relevant frame in the video player. So this is an example of a comparison with the ChatGPT. The question asked is how to draw the shapes. So ChatGPT provides a general responses about the handwriting and digital drawing. In contrast, video queue gives a response that is aligned with lecture content like this. Okay, so here is an example of how video queue works using the Japanese lecture video. So these are a list of the lecture videos. When you enter the question, sorry, this is in Japanese. It says that please let me know how to extract the line in the image by have transform. Because this is a class for the image processing. So then you can also, you receive the answers like this, and you can also watch the related to...
もう一度ではハフ変換の直線
Okay, so to evaluate how well our system selects relevant video frames, we conducted a subject evaluation. Participants were asked to fill out the questionnaire about the validity of the video clip shown along with the answer to their questions. So, as we can see, as a result, 77.1% of the students responded with agree or higher. So that indicates that our system successfully identified the most relevant lecture video clips. To evaluate how effective our system is for the review purposes, we conduct a survey with 319 university students who attend the lectures. So we asked the three questions. First, was it helpful for the review? about 80% of the students responded positively. Second, was the response appropriate? 74% said yes. And finally, would you like to see this implemented in other lectures as well? About 80% of the students agreed. So these results indicates that our system is highly effective and has a strong potential for use in other lectures. So here is an example of a YouTube lecture video. So this is a first principles computer vision lecture series by Professor Shuri Nair from Columbia University. Actually, his channel has 72,000 subscribers and features 151 videos. That's a lot. As February 20th, 2024, his videos have been viewed over 1.9 million times. So here is an example of how VideoQ works using the lecture video. Now you can enter the question here. How to detect the lines in the image. So you can see the answer of the question.
Let's take a look at how this works on a real image. Here is the original.
Next, we will ask, tell me about animal visions. That is another topic. Then answers comes up, and
Very often, although they have two eyes in all of these cases,
related.
very often these two eyes don't overlap.
So last question is how to recognize image in the CNN.
Major innovations in the context of neural networks is the idea of convolution.
Like this. So if you want to try to, please, use this QR code that goes to this URL. All right. So in December 2029, we founded a startup company for the video queue called Evo AI. Our mission is to create a society where humans and AI grow together. So our business focuses on this video queue, B2B and B2C service, bringing AI-powered solution to both businesses and consumers. The CEO of Evo AI is Mr. Yuki Harada. He is my graduate student. Okay, to conclude, VideoQ is a lecture video search dialogue system that leverages LLM and RAG to enhance learning experience. By using the RAG, the system generates responses that are aligned with the lecture context, ensuring the more accurate and relevant answers. Furthermore, by providing the direct link to relevant video segment, we improve the transparency and offer reliable sources of the information that helps to prevent LLM hallucinations. So if you would like to know more about this system, please feel free to contact us. Thank you.
Thank you for the presentation. So this is a totally new approach in Japan. And if you have some question or discussion, please let us know. So that's my presentation. If you have some question and discussion is okay.
Thank you very much for the very interesting presentation and the system. I think the system is very useful for the student. And actually, maybe we would like something similar in Thai MOOC as well, I think, because it is very, as a student, I think it's very useful. So I just would like to know, I know that the AI is require a lot of resource to train and then to run. So in terms of the cost that happen to the system that you developed, and can you share how much estimate cost that we will need, or how much resources that we will need to run this generative AI model on the course content and then to serve the student. Thank you.
Thank you so much. Sorry, I can't hear. Maybe you just ask us using generative AI.
For the RAG system, that you demo, the one that create a virtual assistant, virtual teacher from the video. Okay, I just would like to know how much resources that we need to run this kind of system.
All right. You just asked the previous sensor. Okay. Can you?
Okay. Yes. Actually, yeah, we need servers for working on LLM, and we still need some, how to say, chat system. Okay. So I cannot say how much it is now, but we just started the startup. So yeah, please email me if you are interested.
I can add on. Actually, Dr. Pungtawat is our helping hand in implementing Thai MOOC systems. He is expert in terms of platform development in Thailand. So I am sure that he is interested in working with you, learning from you. So hopefully we can link you up together one day.
Yeah, that's great. Thank you. Thank you for asking.
Thank you. Okay, any more questions? Okay, Kodama Sensei, no more questions.
Yes. Final question is there. Could you tell us in Thailand or Thai MOOC system is already something like use the generative AI or AI technology? Yeah, you just already present the I know, but some other approaches is there? Or how could we collaborate with JMOOCs and Thai MOOCs into the AI or generative AI?
So, my name is Kampon Waradit from Chiang Mai University, Thailand. My university adopt the ChatGPT 04, and so basically we write program to like mask over the ChatGPT. Yeah. So there are 2 layers. So we add one more layer on the top of ChatGPT so that the professor can create a chatbot by writing prompt, try to give as much as details that professor can to tell that chatbot to behave in the way that the professor want. Professor will upload the materials, handouts, or video lectures into the system and can tell the chatbot to answer only the question related to the subject. We can tell the chatbot not to answer something else. If the student asks about something else, don't answer. We can do that. That's the way Chiang Mai University apply the chatbot in teaching, help teacher, help professor teaching the courses. So in this way, it's 24/7 hour. So student can come to access the assistant at any time, even though it's midnight. Sure, certainly. We put the name Matthew. So if you hear Matthew SCMU, that means the chat GPT that we cover one more layers on top. Yeah. Yes. Okay. Thank you.
Thank you so much. The other question or other approaches there? Is okay?
Okay, I can share with you based on our discussion so far in these 2 days. Some universities, they don't have Matthew Sensei. So instead, they pay to ChatGPT and create GPT for their teaching and learning process. So I believe this is another approach if they don't have system like what you have, or if they don't have Matthew. So they can go on their own and then create individual GPT as their service. So that would be another case. Thank you very much, Sensei.
Thank you. So already he said, Professor Fujio Sensei said that this system making the business or just startup business. So we already, then if you collaborate with us, so I want to collaborate with you, our Thai MOOCs in the near future. Thank you so much.
Thank you so much, Kodama Sensei, and thank you also, Professor Furuhashi Sensei. Thank you so much, both of you. You have been wonderful, and we hope that Thai MOOC and also our members here will be able to learn from you and collaborate. Who knows, we are going to have Thai MOOC Sensei in the near future. Thank you so much. Okay.